Hi friends, welcome to my YouTube channel Unlock Math Knowledge. Today I will show you how to find eigenvalues and eigenvectors. Okay, for a 2 by 2 matrix. Okay, step by step in the simplest way possible. So let's see general formula for eigenvalues. Okay, general formula for eigenvalues. What is the general formula for finding the eigenvalues? Okay, so suppose for a 2 by 2 matrix, okay, for a 2 by 2 matrix, suppose A is a matrix which have the entries A, B, C, D. 2 by 2 means 2 row, number of row is 2 and number of column is 2. This represent rows and this represent columns. Okay, so our target is how to find eigenvalues. Actually the formula is for a 2 by 2 matrix, determinant of this is the general formula, determinant of A minus lambda I equal to 0. Lambda is a scalar. So I have to find determinant of A minus lambda I, then I have to equate equal to 0, then the lambda value will be the eigenvalue. So how to find A minus lambda I? First let's find A minus lambda I. So A minus lambda I will be, what is A? A is A minus lambda I equal to A, B, C, D, right? And minus lambda. I is the identity matrix for a 2 by 2 matrix. Identity matrix is diagonal elements are 1 and rest of the element are 0. Okay, so this is A, B, C, D minus lambda multiple, 1 into lambda is lambda, 0, 0, lambda. Okay, then negative, so I have to minus A minus lambda and this is B minus 0. This is the way for obtaining the negative from one matrix to another matrix. So A minus lambda and B minus 0 and C minus 0, that means this to this and this to this. Okay, C minus 0 and D minus lambda. Okay, this is the matrix. So A minus lambda, B, C, D minus lambda. So this is A minus lambda I. So definitely determinant of, therefore determinant of A minus lambda I will be determinant A minus lambda, B, C, D minus lambda. Okay, how to find this determinant? You multiply this diagonal to this, then minus into this to this. Okay, so what is the process? A minus lambda into D minus lambda minus B into C. Okay? B into C. So after finding determinant of A minus lambda I have to equate to 0, then I need to find the eigenvalues. Okay, so this is the way. Now let's take one example for looking more in-depth way. Let's take a matrix 2 by 2 matrix, A equal to 2 1 1 2. So how to find the eigenvalues of this matrix? By finding determinant of A minus lambda I. Lambda is a scalar and I is the identity matrix. So obviously, therefore A minus lambda I will be what? 2 1 1 2 minus lambda into identity, so that means lambda 0 0 lambda, right? Then what will be 2 minus lambda, 1 minus 0, 1 minus 0, 2 minus lambda. Okay, that means 2 minus lambda, 1 1, 2 minus lambda. So therefore determinant of a minus lambda I, determinant is written by this present symbol notation. So this is 2 minus lambda into 2 minus lambda. That means this multiplication of these to this, then negative into this to this, yes or no? So 2 minus lambda into 2 minus lambda minus 1 into 1. So what will be? If I multiply this, 4 minus 2 lambda minus 2 lambda plus lambda square minus 1. So definitely I am going to get lambda square minus 4 lambda. 4 minus 1 is plus 3. Okay. So how to find eigenvalues? I have to equate this part equal to 0. Okay. Because the determinant of a minus lambda I should be equal to 0. Therefore, determinant of a minus lambda I equal to 0 gives what? Lambda square minus 4 lambda plus 3 equal to 0. So can I write this line as a lambda square minus 3 lambda minus lambda plus 3 equal to 0? Can I write this line to this line? Okay. So if I take lambda common from this, so lambda minus 3 and minus 1 common, lambda minus 3 equal to 0. Actually I am factorizing. Okay. So if I take the lambda minus 3 common, so lambda minus 1 equal to 0. What is the meaning of this? Either this equal to 0 or this equal to 0. If lambda minus 3 equal to 0, it gives lambda equal to 3, and if lambda minus 1 equal to 0, then it gives lambda equal to 1. Okay. So I got therefore eigenvalues are 1 and 3. Okay. So how to find eigenvector? So let's see how to find eigenvector. Okay. Eigenvector we need to find corresponding to the eigenvalue. Okay. Once we have lambda means eigenvalue, we can find, okay, eigenvectors from, there is a formula, from where we can find a minus lambda I into x equal to 0, where x is the eigenvector. Okay. X as a x comma y. Okay. So once we have the eigenvalue, we can find eigenvector by using this formula. Okay. A minus lambda I into x equal to 0. Here x is the eigenvector. X is x, y. Okay. So we have the eigenvalue. So let's see. We find the eigenvector. Eigenvector for eigenvalue lambda equal to 3. We need to find this. Let's see how to find. So for lambda equal to 3, so we have a minus lambda I. Okay. A minus lambda I will be what? A minus lambda I. So what is a minus lambda I? From this equation, a minus lambda I means 2 minus lambda, 1, 2 minus lambda. Yes or no? So that means was 2 minus, what is lambda? 3, 1, 1. Yes or no? What is that? 2 minus lambda, 1, 1, 2 minus lambda. Okay. 2 minus lambda means 3. So what will be? So this will be minus 1, 1, 1, minus 1. See, this is row 1, this is R1, suppose then this is R2. R1 and R2 are dependent. That means R1 is multiple of minus 1 into R2. Okay. So how to find the eigenvector? A minus lambda I into x. Therefore a minus lambda means 3, a minus lambda I into x equal to 0 means a minus lambda I means minus 1, 1 minus 1 into xy equal to 0. 0 means 0 vector. Okay, so what? So there will be this multiplication to this, and this will be to this, yes or no? So that means minus 1 into x, that means minus x. Then you have to take the plus 1 into y means y equal to 0. And since these are dependent of each other, so only one is enough. Okay, so from this I can write x equal to y. Okay, so what is eigenvector? Therefore eigenvector x equal to what? X comma y, x and y, x. What is y? Y is equal to x. If I take x common, that is 1 1. Okay, this 1 1 is the eigenvector. Okay, so for lambda equal to 3, eigenvector is eigenvector. Okay, eigenvector is 1 1. Okay, and now for lambda equal to 3 I got 1 1. Okay, now for lambda equal to 3 we obtain the eigenvector, and that is 1 1. Now let's find eigenvector for lambda equal to 1. Okay, then the step to another step is eigenvector. Similarly we can find eigenvector for lambda equal to 1. So similarly a minus lambda I, how to find? For lambda equal to 1, a minus lambda means 1, lambda I into x must be 0, yes or no? So that means what? A means what? A minus lambda I. So what is a minus lambda I? So let's find a minus lambda I equal to 0. Okay, so how to find a minus lambda I? A minus I is what? So what is a minus? What is a minus? That means 2 minus lambda, 2 minus 1 1, 2 minus 1. Okay, so this will be 2 minus lambda, 2 minus 1 1 1, 2 minus 1. Okay, so this will be 1 1 1 1. Okay, so therefore a minus I into x equal to 0 means 1 1 1 1 into x means x comma y equal to 0. See, again the row 1 and row 2 is dependent, so only 1 is enough. So I can write similarly this multiply to this and this multiply to this. So I am getting x plus y equal to 0. So what I am getting? Y equal to minus x. So what is the eigenvector? Eigenvector x is xy, x, y means minus x. If I take x common, then 1 minus 1. Okay, so I am getting the eigenvector 1 minus 1. So what is the eigenvector? So for lambda equal to what? For lambda equal to 1, I am getting eigenvector. Okay, I am getting eigenvector 1 minus 1. Okay, hence finally we got for lambda equal to 3. Okay, the eigenvector is, what is the eigenvector? 1 1. Am I correct? For lambda equal to 3, eigenvector for lambda equal to 3, we got the eigenvector 1 1. Yes, we got the eigenvector 1 1, and for lambda equal to 1, we got the eigenvector as a 1 minus 1. Okay, thank you.